The biggest misconception is when Matter came out, everybody's like, that's it. It's the death of Z-Waves. Matter was never meant to replace everything. Matter was meant to be the umbrella that laid on top of everything, that allowed everybody underneath to communicate with each other.
Welcome to the Technical Difficulties Smart Home Podcast. This week we are joined by Chairman of the Z-Wave Alliance, Avi Rosenthal. He has a lot to share about Z-Wave. Now, obviously, he'd be a terrible chairman if he didn't, but he also has some surprising things to say about Matter. We dive into his history of automating his own home and some of the smart home devices that he has, in fact, invented. We talk a little bit about CES, which is coming up in just a couple weeks. He'll be there, I'll be there, and you know who else is going to be there? That's right, it's our sponsor, Zooz. Zooz makes the smart home Z-Wave devices you can depend on. Sensors, switches, smart plugs, relays, you name it, they've got it. Now, Christmas is only 3 days away, people, but if you order today, and I mean right now, from thesmartesthouse.com, it's probably still not going to get there in time. Plan ahead next year. But you know what? That's probably okay, because Zooz devices, if we're really being honest here, they're just a gift for yourself, right? And not just because they allow you to do all of the cool automations you're always scheming about, but because they take the stress out of doing it. Zooz is the only smart home manufacturer that I know of that gives you a 5-year warranty on all their devices, so you know their devices are going to last. And if you're doing a smart home project that you've never done before, Zooz offers all the support you need. They have an extensive knowledge base with documentation and wiring diagrams for all sorts of scenarios. But if you get in a jam, you can contact customer support and get a response from an actual human being. We're talking about old-fashioned customer service for all your newfangled devices. For the best prices and selection of Zooz devices, visit thesmartesthouse.com. You'll find a link for that in the description below. I know you're going to love it, just like we love Zooz for supporting this show, which we're going to get to right now. All right, we are back, you guys. With me, as always, Brandon is on the show. Brandon, say hello.
Well, hello, Pete. Got a new microphone. Hopefully I sound fantastic for you.
I mean, you sound fantastic. You look fantastic, as always. And so does Vinny. Vinny, how you doing today?
Good morning, San Francisco. Is that what he says?
San Francisco.
What is it? Good morning on
Vietnam.
what's his?
Good morning,
damn it.
Vietnam. You're only
No.
a few thousand miles away.
Will Ferrell movie.
San Diego.
San Diego?
Oh,
Yeah,
San
good morning,
Diego.
San Diego.
San Diego. Yes. I think is where you were going with that. Yes.
Yeah. All right. Well, we have a guest who is I believe he doesn't live in San Francisco. He works with people in San Francisco. He's in the East Coast right now. He is the chair of the Z-Wave Alliance. Avi Rosenthal, thanks for joining us today.
And thanks so much for having me. From what I understand, this has been a long time coming, so I appreciate everybody's patience in getting me on, but I'm looking forward to this.
Yes, and we're excited to have you. As you know, Zooz has been our sponsor for a couple seasons now. So,
Yay, Zooz.
member of the Z-Wave Alliance. So we do have a lot of listeners that are Z-Wave fans, and maybe you'll make a few more Z-Wave fans here today. But why don't you tell the people a little bit about yourself and why you're here?
Absolutely. So it all started in a small radio. No. So I have been in the connected device world now for going on about 35 years, believe it or not. Started when I was just a toddler. And I started out as an integrator. So I was actually the guy doing the installations way back in the day, home theater, alarm systems, things like that. Then I jumped over to the manufacturing side where I became a product developer, and I've designed and developed more than 100 different products, many that are still in people's homes even today. Did that for a number of years with major manufacturers like Legrand and Nortec and others. Did the startup thing because, you have to do the startup thing. And then I became an industry consultant about 9 years ago. So I help lots of companies now design and develop products. But my focus really as a volunteer is on the Z-Wave Alliance. And so I became the chair of the Z-Wave Alliance about 3 years ago. We have gone through some major changes at Z-Wave, some very exciting stuff. We became a standards development organization, or SDO, as we like to say in business. And that allowed the software freedom. So when Scilabs acquired it, they really set it free, became an open standard, allowed it to really thrive within the marketplace. We now have multiple silicon vendors. We have lots of software being contributed to us. We're part of a lot of other open standards as well. And now we play nice with everybody in the sandbox. And it's really cool. And it's a very exciting time to be part of the Z-Wave Alliance.
So the Z-Wave Alliance sounds like a military organization. Is that correct?
It's more like the Rebel Alliance from Star Wars, not
Oh,
the
okay.
military. Yeah, because we're a family. One of the things that people love about being members is this camaraderie. We just had our annual U.S. Summit out in Carlsbad a couple of weeks ago. We had more than 100 folks show up, and it's very much collaborative. We have joint sessions. There's co-opetition, if you will, because one of the things about Z-Wave is its interoperability. So all of the products talk to all the other products. That's one of the things that we are very serious about. And because we foster that interoperability in our design of our devices, it really fosters interoperability within our members as well. We're a very tight-knit group, a lot of family aspects to it. And of course, you take the good with the bad, right? Because there's a lot of drama sometimes. But in all honesty, it's a really, really fun week. We had a great time. We did something called the Unplug Fest. A lot of other organizations do a Plug Fest where they do interoperability testing. Because everything we do is wireless, we did the Unplug test. And I'm here to tell you that Z-Wave Long Range, we did a really cool thing. We had a guy jump out of an airplane from like 10,000 feet. And we tested Z-Wave Long Range all the way down to the ground. He survived, the devices survived, and we showed some really great range. We can actually prove Z-Wave Long Range will communicate full bandwidth over 6 miles. 6 miles. Now, there are other RF standards, obviously, that will communicate longer distances. However, when Z-Wave does it, we do it full bandwidth, full encryption, don't lose a bit. Totally precision communication out 6 miles with standard devices. Nothing crazy, stuff you can buy off the shelf today.
So I know a lot of people. Z-Wave Long Range is kind of still fairly new. I mean, it came out a few years ago, but it's still, as far as adoption.
It's gaining ground. Absolutely, it is very new.
Can you tell people a little bit about the difference between Z-Wave and this Z-Wave Long Range?
Sure. So Z-Wave has been around since actually 2003. So it's well over 20 years now, and the classic version, the Z-Wave that everybody knows and loves, is a mesh operation, right? So it does hops through devices, and that's how it gains range. Some of the engineers about 4 years ago were tinkering around in the lab, and they realized that if they tweaked the modulation slightly, they could actually create point-to-point networks. And because of the way that we operate at a sub-gigahertz frequency range, in that 900 megahertz range, based on the FCC rules and the rules in Europe and around the world, we can actually pump more power into our point-to-point devices. And so we developed something called Z-Wave Long Range. And what that did was it enabled us to send full bandwidth, fully encrypted devices, communication point-to-point from a controller to a device for an exceedingly long range. And because we have bi-directional communication in that range, we actually have the ability to receive an acknowledgement. And that's how we know that in 6 miles we were able to communicate, and we got good full pull through. We got great range, and we know that it was fully encrypted. We're able to then link those two networks together. So you can have a mesh network and a point-to-point network all within the same architecture. So think about a college campus, right? You do the dorm rooms. The dorm rooms are all going to be mesh network because they're all contained within one building. But if you want to send those signals across campus, you would have to like convert to Wi-Fi, get on somebody else's network, worry about a sonnet ring, worry about long range or something like that, and then convert everything back. Now with Z-Wave Long Range, I can actually send the exact same signal that I'm communicating within that building across campus to another building to either affect change. Let's say there's a campus-wide event and I want everybody to know about it. With very, very low latency, I can now communicate across that entire network. Oil and gas, agriculture, industrial. These are all environments and different kinds of industries that Z-Wave has never really had the opportunity to play in because we were sort of this short distance mesh network, which doesn't work in a lot of industrial type applications. Now with Z-Wave Long Range, we're getting inquiries from all kinds of different industries that we've never even entertained before. So it's a very exciting time to be part of the Z-Wave Alliance.
I want to put you on the spot a little bit here about the Z-Wave Long Range because I've tested out. I use Z-Wave Long Range in my house. It's definitely, I prefer it to the old Z-Wave 100% as far as reliability and range for sure. But the range, I tested the range. I couldn't get anything close to the 6 miles that you're talking about. I actually my plan was to put a secret sensor at the tennis court so I could tell if someone was on the tennis court or not, so I didn't have to drive there and check. But
then you get down there and they're playing pickleball and you're like, oh.
Right?
We're
I
for
know, get
real
those
tennis.
pickleballers out of there, man.
Right?
Um,
So there's still a lot of development being done in Z-Wave long range. And so you may have a device that the antenna wasn't perfect or there was some sort of major interference. I could tell you that we're getting on average about 1.5 miles through neighborhoods, right? When we say neighborhoods, stick and brick kind of buildings, right? Asphalt roofs, lots of appliances, at every home, things like that. So it'd be interesting to see like what your environment was and what it was going through and what the range looked like. It also has to do with the placement of your controller, all right, where your controller is. Obviously, our 6 miles was done open air. I'm not pulling any punches. We're going to publish a report, tell you exactly how we did it. But we have done 1.5 to 2 mile within neighborhoods, homes, trees, buildings, cars, all kinds of other, things that go in and interfere with signals. So I'd love to take a look at what yours look like and to understand, where the tennis court was. A lot of tennis courts have, chain link fences around them. Was yours grounded,
right. Well,
thereby creating a
I didn't get
Faraday
anywhere
cage,
close to the
right?
tennis court yet. I lost signal way before I got there. That's
Oh,
what
you
it
even
was.
got there. Now, then
Yeah.
we should take a look. And I don't want to put any of my members on the spot, right? Because, it all depends
Right.
on who built the sensor and who did the engineering and things
Right.
like that.
And the controller, that
yeah.
is there a controller you know of that like works with the Z-Wave long range better than?
So the Home Assistant ZWA-2 is the best Z-Wave controller right now for range.
Also massive.
Yes. Well, we're dealing with physics here, boys and girls, right? There is just the,
Size
it's
does
only
matter.
about, I don't know how big my frame is on your recording there, but it's about 12 inches tall. It is massive by other aspects, but
I've seen other YouTubers and creators use it as a paper towel dispenser. They put a paper
yes,
towel over there.
yes, paper towel roll fits beautifully over
Nice.
it. You got to deal with what you got to deal with, but I can tell you, Pete, that if you put this in my own home, I put it a little higher than some of the other things, and it has incredible disbursement. I live now on the 14th story of a high rise, and I can see my Z-Wave devices in the parking lot. So that's
You're just using the wrong stick, maybe, Pete.
yeah. If you're using a little USB stick or a little controller, it's not as perfect. But I will say our friends at Zooz do a very great implementation of Z-Wave long range.
For those that are new to Z-Wave, so how do you describe what the Z-Wave Alliance is, and then what role do you play like in the smart home ecosystem?
Absolutely. So again, been around for 20 plus years. So our role at the Z-Wave Alliance originally was the governance of the technology itself, of the protocol. Now our role has changed because we're an SDO. The source code is all out in the open, right? You can get on the GitHub, log into the GitHub, and you can download, snippets, the whole thing. You can change it. There are companies out there actually that have taken the entire Z-Wave ecosystem and altered it for their use. Don't call it Z-Wave anymore, but are now using it for their own stuff. And that's totally fine. We have no issue with that. But the role of the Alliance is obviously to promote the technology, which I'm here doing right now. We also certify all the products. So if you want to carry the Z-Wave logo and you want to be interoperable and backward compatible, you go through a certification process. And that process is governed by the Z-Wave Alliance themselves. And that Alliance, by the way, is made up of our members, right? So all of the members of the Alliance have the opportunity to sit on the working groups and the technology groups, and they steer the technology and they steer the protocol. So just this past year, for instance, we made 2 major changes to the protocol. One was a command class all about scheduling, and the other was a command class all about credentialing for door locks. We're very big in door locks at the Z-Wave Alliance. Access control is a big deal for us. Because of our roots in the security industry, virtually every security panel in America, with the exception of only one major brand, has a Z-Wave chip in it as a standard. So if you have
What the heck is
panel,
their problem?
I don't want to talk about it. We're not calling names. The
Is
Z-Wave
this like
Alliance, we're all
the
about
9 and 10
stand.
dentists approve the toothpaste? Is that...
Exactly. That's 4 out of 5 Trident users. Exactly. 4 out of 5, dentists approve of the use of Trident, and 9 out of 10 security companies.
The last one was smart. He wanted the additional business. He's like, you don't want to use this toothpaste.
You don't want to
too
use
good.
this stuff. So I'm just
Come
saying, there's
back.
one guy.
I
But
recommend sugar. It's the best way to brush your teeth.
best way to
Job
brush your teeth.
security.
It's nice and gritty. It gets right into the
Yeah.
nooks and crannies, Brandon. You gotta
Really
get
good for
it.
the dentist.
Fair point.
But
He's got
the
college to
Z-Wave
pay for.
Alliance is all about kumbaya of the technologies. As a matter of fact, one of the really cool things that's come out of us being an SDO is the other protocols, the other technologies, things like LoRa and Wi-SUN and Wi-Fi and Bluetooth and Thread, we all meet on a regular basis now as equals amongst the various leaders within the alliances to talk about how we can better leverage what our technologies do best, where we can fill in gaps for others, where we can work together. And you'll notice that Matter is also a part of that. So CSA, I have regular conversations with the folks from CSA. CSA is a great bridging technology. As a matter of fact, they just announced at their conference, what was it, last week? Some more bridging technology and some more bridging opportunities. You'll notice that there are some big players that are now lining up to produce bridges for Matter, and we're lining up just as well. There'll be Z-Wave to Matter bridges. There'll be the opportunity to connect those ecosystems together. Watch this space for major announcements happening at CES, my favorite week of the year, where we will be talking a lot about how the Z-Wave protocol is going to change in 2026 for the better, how we're going to broaden the base, how we're going to have more connective tissues for things. What people really love about Z-Wave and the reason why it's been so successful is our application layer, our top layer of our network stack is bar none the best in the industry. I will stack it up, against any of the others out there. It is more robust. It is more well vetted. It has got 25 years practically of development behind it. And that application layer is really the power of the Z-Wave Alliance and the power of the Z-Wave protocol. And so although others may argue, 900 megahertz is better or 2.4 is better or 5.8, or now you're getting 6 gigahertz, we can debate transport layers all day. Application layer is all about where the rubber meets the road, where the user interfaces with the product. And that's where it's important to have robust technologies, robust infrastructure, and robust command classes. And that's what Z-Wave is all about.
Okay, so you used a lot of words there that I don't understand. Application layers and things like that. How does what you just said apply to a homeowner in what they're choosing Z-Wave?
Okay, so without going very technical, I'm going to give you the railroad analogy. All right, so there are 8 layers in a network architecture. Don't worry about the 8 layers. Let's talk about a railroad. A railroad has tracks, a railroad has wheels, a railroad has cars, and a railroad has engines. All right, so those are the things that we're most worried about. The transport layer is what allows the train to go down the tracks in a standard way, right? Every railroad car fits on every track because the transport layer is the same exact size, right? And we can get into why the Romans decided it was that wide, but that's a whole other thing for later on. So
Well, now I'm
that's
curious.
the transport layer, right? The type of cargo that it can carry is important as well. That's how the packets go together. So some cars carry cargo, some carry livestock, some carry gas, some carry orange juice, some carry, doesn't matter. Those are exactly what the packets are all about. You have IP packets, you have QAM packets, you have all kinds of different packets. They go on the cars, but they all move down the same track. That's the transport layer. The application layer is the very top line. The top of the stack is the application layer, and that's how you and I drive the train. So Matter, the reason why Matter was so revolutionary is because it took all of the 7 layers underneath it, and it sort of said, we don't really care how those layers are going about. I mean, we care a little bit, but not completely. We're mostly concerned that the data layer, the layer at the very top, is consistent and is interoperable amongst many different players. And so if everybody plays with the same application layer, it means that you have interoperability. So the good news there is that Matter said, here are the rules of the road, and here's how you interface with our system. The bad news is they had to start from scratch. They had no basis of where they were starting from. They used a little bit of something called Weave. They used a little bit of something called Thread. They used, obviously, IP packets. So they established certain things, but the application layer, the command classes, if you will, everybody got in a room and sat down and said, okay, when I turn on a light, I want to see this command structure come from the controller to say, I want the light to go on. Now, just like building a railroad, building an application layer is a complex thing. There's lots of different stakeholders, there's lots of different opinions, there's lots of different ways of doing it. And that's sort of the reason why Matter had what can be described as some fits and starts in the beginning, right? They've
To your
now got
humans.
the train
Or,
running, right? Well, I don't want to speak ill of anybody. They I have said this publicly before. I'll say it again. They had to do this with the bright spotlight of CNN and The Verge and the New York Times shining on them as they did it.
Well,
That
that's
is
kind of their own fault. If you,
yeah,
they brought that on
but
themselves.
right. I mean, when you have an Amazon and an Apple and a Facebook, you have all these huge names in Google, right? All with PR agencies, all screaming about this, then yeah, it's going to be a problem. But the bad news is everybody was watching them do this. I mean, I can tell you Z-Wave developed in anonymity 20 years ago when nobody even realized what any of this stuff was. And it was a much easier way to do it. So, I have lots of sympathy for what they've gone through. But now they've got the train on the tracks and things are moving and you're seeing some pickup of matter. But like if I design a Z-Wave matter bridge, the first problem I have is there are hundreds and hundreds of commands that I can leverage in Z-Wave that I can't leverage in matter because they just aren't simply there yet. So it's sort of like having lots and lots of train tracks, but there's no station, right? Because Z-Wave has tons and tons of stations, but the matter train doesn't know how to stop at those stations because it doesn't understand how to communicate there. So that will change over time. Matter will grow, matter will succeed, they will evolve, and that will solve itself. Meanwhile, Z-Wave is still flourishing. We're still doing our thing. And now what we are going to be able to do is take the subset of commands and say, hey, wouldn't it be interesting if the Philips Hue guys who adhere to Matter protocol, and by the way, the Philips Hue guys are a perfect example because they have lots of commands that a Philips Hue controller will do that not necessarily a Matter controller will do, right? Not every command is exposed yet. But wouldn't it be cool if a Matter controller could then talk to a Z-Wave device, at least in the subset of commands? Something to think about. So the application layer is the important part. That's actually where the rubber meets the road. That's where the developers write the code. That's where the user interfaces reside. That's how everybody sort of communicates with one another. So forget the train tracks and forget the cars and the color of the car and the kind of engine and all of that. Let's talk about how, when I get to a station, how I talk to everybody. That's the important part. And so that's the part that Z-Wave has spent the better part of 25 years developing very successfully. And because we're now an open standard, we get lots of input from lots of other people, which is great because more minds, more thinkers, more ideas, more contribution improves everybody.
So you hear a lot of like people in general, like you hear matter and assume that everything else is going away. So like what's Z-Wave's role, like kind of in as we move more towards like a matter driven
and that's the first problem is matter was never meant to replace everything. Matter was meant to be the umbrella that laid on top of everything, that allowed everybody underneath to communicate with each other. Matter was never meant to be this ubiquitous one-stop shop, because remember, it's an application layer. The other 7 layers underneath it, you can have Thread, you can have Wi-Fi, you can have Zigbee, you can have Bluetooth, there's a whole bunch of choices there. And some folks have chosen one, some folks have chosen another. The Matter folks don't care, right? It's just the application layer. So I think the problem, and again, this goes back to the PR issue that Pete mentioned, is when you get, Google standing up there and going, we will fix all the problems and they will all be done and everything's going to be hunky-dory and well, they sort of forget the fact that there's a whole bunch of other things that have to come along for the ride. And so that's why you'll notice that Matter has sort of softened that stance. And we're not meant to replace the world. We're meant to enhance the world. And I truly believe that they will at some point enhance the world. They're going to make it easier for users to use devices. They're going to make it easier for users to configure things. I mean, that is their role in life. And I do believe that that's where they're headed. But I don't think they're going to eat the world like AI will, right? Or something else will. I think that they're going to be another arrow in the quiver of smart home or smart device or IoT or whatever you want to call it this week, right? They're just going to be another opportunity for people to have devices communicating with each other. And it's not a VHS beta problem, right? It's more of a, how does everybody get along problem? It's a ATSC 3.0. There's lots of different choices but everything's digital television.
Right. So where do you see then Z-Wave? You say we looking at Matter working with Z-Wave in some capacity
Mhm.
in the future. So where does Z-Wave really shine? Like what types of specific applications, devices
Yep.
is Z-Wave the best in
So
the business at?
low power, battery operated, or now you'll actually next year have battery less devices that are able to collect energy on their own, and not even need a battery. Encryption, backwards compatibility, interoperability. Those are the key phrases when you think of Z-Wave devices. So let's talk about where our real strength is. So in residential homes right now, that's definitely our sweet spot. Sensors, door locks, thermostats, security, lighting control, right? That, you can do anything within your home with a Z-Wave device. You want to turn off your water. You want to check for leaks. You want to see what your indoor air quality is. You want to lock or unlock your front door. You want to know if your garage door is up. You want to check the temperature, your energy usage. Anything that you can think of within your home that you can sensor control can be done with a Z-Wave device. That's been our sweet spot. Z-Wave long range is now expanding outside the home to do lots of other applications as well. Oil and gas fields, agriculture, grow houses, campuses, enterprise, industry, data center. There's a whole bunch of things now that we can do. Right now, for instance, data centers have all these wired sensors in them to tell them what's going on within a data center. Imagine if I can place a sensor where the problem is rather than worrying about whether or not I have a wire going to that location to wire in a sensor. Smoke and CO, indoor air quality, temperature, all kinds of things in battery operated devices. A lot of the other protocols can't do that because of their overhead.
You talked about batteryless or powerless devices.
Mhm.
How do those work?
How do they work? All right. So
They don't. They don't. I made that up right here on the spot.
exactly. There you go. Okay. So you're ready. So there's there's a theory of a magnet circulating within a coil. Now, when a magnet circulates within a coil, it generates electricity. It moves electrons, thereby generating electricity. If you are very efficient in the way that you can grab the electrons as they are stimulated in that little rotation, you can use that power to charge a circuit to send a message. So there's a really cool company on Long Island called WePower, and they have figured out a really cool way of collecting those electrons and allowing them to be used in lots of radio devices. And Z-Wave is one of the first devices that they are going to use because of its low power nature. So they can do it with some Zigbee stuff, they can do it with some Bluetooth stuff, but we're really focused on obviously Z-Wave because we think that there can be some really cool applications, things like interrupt switches. So if you know anything about the way that manufacturing works,
I
there's
do
a
not.
line of assembly. And during the line of assembly, if anything goes wrong whatsoever, you have to be able to push a button within a very specific location and stop everything. And that's called an interrupt switch because you are interrupting the manufacturer. So the problem with interrupt switches is when you reconfigure your manufacturing, everything is wired and you have to move everything around and you have to rewire everything. And it takes days and days and days and it's a real pain in the neck. And then it has to be inspected and somebody has to come in and verify it and somebody has to make sure that it's working properly. And so it's a real pain. Imagine an interrupt switch that you hold in your hand and you walk from place to place. And if there's a problem, you push a button and boom, you interrupt. And you never have to worry about changing a battery. And you never have to worry about it being charged or it being ready. It's always ready.
And that would also be safer too, because you don't have to run
Right.
to the spot. The operator can just have it on them, right? They can just, yeah.
And because we operate at 900 megahertz, we don't get interfered with in a lot of these dirty RF places where they've got to have very strong Wi-Fi and very strong Bluetooth to control the other big machinery, right? The backnet systems and the industrial systems. So because we're at 900 megahertz, we have nice clean air to operate in. And so now, very low latency, push that button, get that safety going. Works the same way in your home too, right? If you're standing outside, pouring rain, full of groceries, and you want your door to unlock, you want to be able to tap that button and you want your door to unlock, right? Or there's a storm coming, you want to make sure that your garage door is closed. You tap that button, your garage door closes. Lighting controls. I just moved into a brand new apartment. Those of you who know me know that my wife and I just downsized. All of our children are out of the house and off the payroll, so we downsized. And the first thing I noticed is that the light switches are in really strange places because I don't know who designed this place. So I want to be able to, what we call in the industry, lick and stick light switches wherever I want them, so that when I enter a room or I go to a different area in the apartment, I can turn the lights on and off. Well, you can do that with battery operated devices today, but how cool would it be to do it where you never have to change a battery? Where you lick
Mhm.
and stick that switch, you can hit it a million times. It doesn't matter how many times you tap it, and the battery never dies.
You know what? That's
So
actually
Philips Hue has this, the tap.
Philips Hue has a limited version of it that they use a standard called Enotion. And Enotion only works in very limited range, and it only works one way. The beauty of this system is it would still be two-way and it would still be full bandwidth. And even if it was further away, it would still assure communication because it was a two-way link.
Yeah, take that, Philips Hue.
Or come on down, Philips Hue, and let us show you a better way to control your devices.
Now, does this technology only work for like a device that requires some sort of physical movement? Is that where it gets the power from?
Today it collects the energy from movement. That movement can be things like vibration, circular movement in tires for TPMS sensors,
Okay.
right? The door opening and closing, right? So you could put it on a hinge. So as the door opens and closes, it collects that energy, or a push button, right?
Right.
Push the button.
But a motion sensor stuck on the wall is not going to. You need some sort of
Not
motion.
quite
Okay.
yet. No, we're
Okay.
going to do that other ways. There's lots of other ways.
I think a lot of people consider Z-Wave kind of an old technology. It sounds like you're. I mean, I'm just saying if
Seasoned,
that's
seasoned,
seasoned,
experience.
it's
It
seasoned
is
experience.
Experienced, yeah.
Yes, it is a wizened technology.
So yeah, are there any misconceptions you want to like kind of clear up around
first of all,
that?
the biggest misconception is when Matter came out, everybody's like, that's it. It's the death of Z-Wave. Z-Wave is dying. There's no more Z-Wave. There's no more reason for Z-Wave. And there you go. Well, I'm here to tell you, the famous Mark Twain quote, right, is that my death has been greatly exaggerated. We're still here. As a matter of fact, we're thriving. Our numbers are up. Our membership is up. Our technology is doing really well. We've announced lots and lots of really great things. We've got CES coming up in just a short while, my favorite week of the year, as I like to tell everybody, to get things going and to do things well, and more power to them. But they're not meant to replace the world, right? That's not their goal, like we talked about earlier. So Z-Wave is still going to be there. And by the way, so is Thread, so is LoRa, so is Wi-Fi, so is Wi-Sun, so is Bluetooth. Each of these RF technologies has its place in its protocol, right? It's got its strengths, it's got its weaknesses. I consult with companies in my day job all the time, and I help them design and develop products. And yes, I have a little soft spot in my heart for Z-Wave. Of course I do. I've been working with it for 20 years. But I have plenty of products that have come out in the last couple of years that don't have Z-Wave chips in them because it's not appropriate for that application. I know. They hate when I say this, but it's the truth. The right application for the right application.
So, what are some devices that are not the right choice for Z-Wave? Like
cellular communication, for instance, right? Really high bandwidth. If you want to send video, Z-Wave is not your thing. We are incredibly great at command and control, but you can't send video over Z-Wave. There's not a bandwidth, right? You want to do a video device, there's other solutions out there. So, I mean, there are specific needs, specific goals, right, that you use various technologies for. And again, that's the beauty of it, is it's a big, big world, ladies and gentlemen. There are billions and billions of RF devices being built every year. You don't have to own them all. There's plenty of room out there for us to all get along and to be part of the ecosystems and to, boost everybody's strengths and to interoperate and work together.
So you've made, you said you have made over 100 devices. Is that what you said, or products in your your day?
I've developed well over 100 products in my year.
Okay, and several of them are Z-Wave products. I'm assuming.
Yes.
So is it easy to make a Z-Wave product? Is it more difficult?
It's getting easier. So like everything else in engineering, when you first start out with a new technology, it's hard, right? If you're going to be the pioneer, you're going to get the arrows in your back. That's the way the saying goes. It's hard. These days, it's become much, much easier. Because Z-Wave is now an open standard, there are really great development tools that are available. A number of them were just announced at the US Summit a couple of weeks ago that make it very easy for companies to design and develop. go out to the GitHub, they download snippets of code, they can use that code in their own devices and build upon them, and they're very, very straightforward. And so we're actually seeing the development cycle in Z-Wave devices drop from a couple of years to now a matter of months. And that's a very big deal. So if you're a manufacturer of consumer product, or a manufacturer of connected devices product, or a manufacturer of industrial product, and you have a really great idea and you want to get that idea to market, the struggle within these organizations is always between marketing and engineering, because marketing comes up with a really cool idea and they want it out in the market as soon as possible so that the salespeople can sell it.
Mhm.
And the engineers always take, because I'm a marketer, and I would go and, beat my engineers about the head and shoulders, like, come on, you're killing me. We thought of this 18 months ago. I went to leadership. I got you funded. Now I need revenue. And so the beauty now is we've reduced those cycles. We've reduced those development time down to a matter of months. So we made the marketing people happy. We've made the engineers happy. They can design and develop product and get them tested much easier than they could before. And so that's really driving a lot of the innovation through the certification, is this idea that you can get product out the door in a much more timely fashion.
Yeah.
What trends are you seeing in the type of devices being added, like to Z-Wave?
So we've always had a sweet spot for door locks. We've always had a sweet spot for lighting control, right? So those are still probably our two most popular genre, I guess, right? Sensors. There's a lot of very interesting work being done in sensors, because the sensor technology itself, like, it used to take a mains power, a plug-in device to do indoor air quality, because you had to charge certain sensors within the device all the time. And now we're starting to see battery operated indoor air quality sensors. And obviously the Z-Wave transmission part of it has always been low power, but the sensor itself is getting better. We're seeing cameraless camera devices. So what do I mean by that? Motion sensors are really good at doing gross movement sensing, right? So if I wave my hand in front of the camera, you can see the movement. And so a PIR, if you know anything about the way passive infrared works, is it's fingers of infrared energy, and something has to break through the fingers in order for it to see the reflection of the person or the cat or the dog or what have you, and then it interprets what it is. However, in age in place, that gross movement, that large movement, is much more difficult to track aging in place in events, right? A slow moving older adult, or an adult that is laying down and needs to move over. So millimeter wave and other technologies now are coming out that are battery operated, that are moving towards battery operation because of their efficiency. And Z-Wave is at the forefront of that, because aging in place, if you're not aware, we're all getting a little older. And so as we get a little older, our parents are getting a little older. And so what that means is that we've got to put systems in place, because our folks all want to stay within their own environments, right? They don't want to go to the old folks home,
Right.
because, my 85-year-old mother will tell you that's for the old people. Like, I don't want to go there. That's where the old people live. And I keep saying, Mom, you're 85. Like, you're one of the old people, but she doesn't see it that way. So she wants to stay in her own environment, right? And that's the trend these days, is that the older folks want to stay in their own environment, but unfortunately, they are getting older. So you want to track them. You want to track their movements. You want to make sure that they're okay. You want to make sure they haven't left a pot on the stove. You want to make sure that they're moving in their environment. And that's
Fall
where Z-Wave
detection.
comes in. Right, exactly. Fall detection. Z-Wave comes in really handy, because you can have mesh devices and you can have battery operated devices that work hand in hand at low power. Because of course, mom's not going to remember to change the batteries in the device, right? I
Right.
mean, it's not going to be a thing. So
Or,
you've got to make sure
probably
that
couldn't change the devices, right? Like
well,
it
I
might be so
give my
small.
mom props. She's gotten good at changing the batteries in her thermostat, because her thermostat every 6 months needs more batteries, and so she's
I
got
just saying, some of the devices, they're so hard to get. I have trouble changing the batteries.
changing the back. Yeah, that was the learning curve with mom. Also, was getting the door off the. That's the hardest part, right? Anybody can put the batteries in, but it's getting. Then a lot of them come with safety screws these days, and that's a hard thing. You got to get the glasses and
Very little.
and
Very
see
little.
the
Yeah.
things, right? But that's the beauty of some of these newer technologies, that the batteries last a really long time. Like, we have door window sensors now. The batteries will last almost 10 years. So that, I mean, then we don't have to worry about things like that. So the trend in Z-Wave is more of this sensing capability, whether it's age in place, whether it's industrial sensing, air quality sensing, movement sensing, using other technologies other than just, passive infrared. Lots of really cool ideas that are coming out that we're starting to see trends on. And so that's, again, because we've lowered the barrier to development. People are now spending the time on the device rather than on the communication protocol.
So does the Z-Wave Alliance do anything to market directly to the consumers about the benefits of like the low power consumption, so that they're choosing Z-Wave devices instead of like Wi-Fi? An example would be like our front door lock. If you're in a colder climate like us, if you have a Wi-Fi one, you're probably gonna have to replace those batteries every 3 months. But if you had the Z-Wave, it might last longer. So is that message being communicated by the alliance, or is that something that the manufacturers are having to do on their own?
So we support the manufacturers in that effort. We do have a customer-facing website for Z-Wave, right? zwave.com is a customer-facing website. And then, of course, the zwavealliance.org, and that's the website for, the members and the developers and the engineers who want to get more involved. We do some, but quite honestly, there's a lot of noise out there when it comes to choosing a device. And I would much rather the homeowner choose the device that fits the need and choose the device that solves the problem they're trying to solve. And I see it much more as the alliance's role of making sure that the devices that we're getting out into the world solve the right problems. So it's not just a marketing exercise. It's if you want the best product for the problem you're trying to solve, you're going to reach for a Z-Wave device because of its features, not because you got on our website and it's like, oh yeah, Z-Wave, look for the logo. It's, that's a much more difficult story to tell to the average consumer than it is putting out great devices that when they have a problem, they get on, they do a search online and they ask their favorite, AI bot, I have this problem. What device do you think I should put in? And the AI bot goes out and scrapes things and says, oh, this is the right device. It's a Zooz lighting control system that doesn't require a neutral, that is a really cool 3-way switch. And it happens to be Z-Wave.
What a deal. So again,
So
you've made 100 devices. So you know about the kind of devices that work. Tell me about a device that didn't solve the right problem. Tell me about one of the devices you made that nobody wanted it. It didn't quite work out.
Okay. Let's see.
there's just so many,
Yeah, right. No, there's so few. Okay. I will admit right here on your podcast, I did not get the doorbell camera revolution. I was in on the doorbell camera revolution day one. I was working for a company called Nortec at the time, and the Skybell folks came to us and said, we have this really cool idea for a doorbell camera. And I looked at my team. I was running the connected device division at the time, and I looked at my team and I went, who the hell's going to buy one of those? Why would you? They already exist. AI phone had been around for decades, right? King had been around for decades. I'm like, what? This already exists. These guys are crazy. This is never going to work. So I will admit right here, that was one of my, it's rare. I will also admit that. I like to think it's rare. I mean, others can chime in the comments now, because all my buddies in the industry are going to watch this and they're going to go, oh, I remember a time when you didn't, right? So I will admit that was a miss for me. But we tend to do in my career, at least, I've always tended to do products that filled a need. So we would identify the need and then we would fill it. One of those, for instance, was I was part of the development team for the Z-Wave garage door opener. So there were lots of different alarm sensors and thermostats and lighting controls and things in the market. And we sat down and we were brainstorming what was one area of the home that Z-Wave had not taken any advantage of whatsoever.
Like
And
waffle makers.
Right. Well, exactly. And that's a different one. But we saw the garage doors, and because again, I was with Nortec at the time, and Nortec had a division that made garage door openers. And so our original idea was, why don't we just build, a garage door opener with connective tissue in it, right? And do it that way. And I was like, well, that's great, but we only sell X number. I don't even remember what the number was. We only sell X number of garage doors, and there were like 100 million homes out there that already had garage door openers in them. Like, maybe there's a way that we can do this. So we started doing research, so we invented One of my patents was on the Z-Wave garage door opener.
One of my patents. I like the way you put it. Just one of them. Just
Well, you know, you gotta
among the many.
it's not many. It's only a couple, but it was a proud moment for me. You know, as a shade tree inventor, right? To have a patent in your name is a very big deal for me in life. So that was one, and that actually did really well. Until the garage door companies all decided to digitize the way that they communicated with the button on the wall, which sort of negated the idea that because our device essentially just clamped that button. You know, all you were doing when you pushed the button in your garage was closing a circuit,
Power, yeah.
right? And it
Yep.
closed that circuit and it told the door to go up and down. And so we just mimicked that in our controller. And then the smart guys at Chamberlain all decided that they would digitize the signal from your garage door opener to the button on the wall, which you didn't need to do. There was nothing wrong with the way you were communicating,
They
but
just
they
didn't
Did they
want you.
claim it was for security, or
that's how my queue became a big deal, because now only they can control their own garage door.
So you've moved 12 times, you said?
Yeah.
14. Okay, you've moved 12 times. You've probably automated most, if not all, of those houses.
I have been automating my home since 1993.
Okay, so whether it's Z-Wave or others, can you just give our listeners the top tips you have for automating your home? What would you say are the most important things about automating
The
your home?
first thing you do is marry a partner that enjoys having an automated home.
Oh, there you go.
Okay, so that's the very
Agreed.
first tip.
spouse approval factor?
I don't care who your partner
Very
is,
important.
but
Yeah.
they have to like living in an automated home. My wife, when I first came to her with the idea of automating our home way back when, looked at me like, why? Can't you just walk over to a light switch? Like, what's the big deal? And now when we move, the very first thing I am told to do is to put in the automated lights and thermostats, because she doesn't like we don't carry keys, right? We don't carry, we live in an automated home, in a modern home. So like Alexa was the first thing that I set up in the new house to make sure that, okay, so that's number one. Number two is you got to have good internet. Everybody knows that. So we're lucky here. I have fiber to the home, fiber right to the apartment. Actually, it's really cool. But in my house, again, you would think, being the chair of the Z-Wave Alliance, I would only use Z-Wave devices. Nope. I have a hybrid, right? I use the device that fits the problem I'm trying to solve. I've got Thread light bulbs. I've got Wi-Fi devices. I've got some Bluetooth stuff. I have lots of Z-Wave devices, obviously. But I've got some Thread devices that I like to play with, because Thread, talks directly to my Amazon devices. I'm an Amazon guy. Sorry, Google. I use the solution that fits the bill. One of the tasks that I had to do here was, we have a big open room that my wife wanted half of that room to be a dining room, half of that room to be a living room, but it was wired on one light switch. So if you replace the light switch, the lights all go on and off all at once. So I got a whole bunch of Thread bulbs and I put them in, and now I can section them off so that I can, ask my A word to turn on the living room versus the dining room, and it works that way. So again, the advice that I give to people is, solve the problem. Don't worry about the technology, right? The technology should be seamless. It's all about finding the right solution to the problem that you're trying to solve. And look, there are still difficulties. I'm dealing with one here. I mentioned the fact that there's fiber to each one of these apartments. And so the company that put in the fiber put a really sophisticated wireless router at the end of each one of those fiber. So there's 350 units in this apartment building, and they all have Wi-Fi 6, and they all have these really, really strong whole home routers in each apartment. The RF energy in this building, I'm telling you, you could see it from the moon. It just wrecks everything. All my 2.4 devices were just getting crushed. And I didn't understand why, and I didn't understand how. And so a buddy of mine sent me a spectrum analyzer, and I turned it on, and it went bright white.
It blew up the analyzer.
It did. The analyzer went poop. Between like 2.3 and 2.6, it was just white. And I'm like, what the? Right. So of course, all of my 2.4s are fighting for every channel. But how does the average user deal with that? How would the average user even know? They'd buy the product, they turn it on, it wouldn't work. They try 3 times, maybe, and it would go back to Amazon, or go back to Best Buy, right? And even some installers would come here and they'd go, why is nothing working? It doesn't make any sense. And so, I know enough about channels and things to move things around, but that kind of thing still is a concern of mine as somebody who sells smart devices to people. It's worrisome that most consumers, you know, I give the advice all the time, go find yourself a good integrator, right? Because I love integrators. I was one, I is one, whatever you want to say, right? But go get yourself a good integrator and they'll help you do this. But not everybody wants somebody in their home and not everybody needs that sophisticated a system. You want to, get
Or
on
they
Amazon,
can't
order some
afford it.
smart bulbs and things, right? It shouldn't be that hard. But
Yeah.
because we can't, as human beings, can't see RF energy, we have no idea how much there is. It's sort of like electricity, right? Whenever I work with electricity, I always think to myself, like, why haven't humans evolved to the point where we can see electricity? Because it hurts if it's there, right? And you touch it. It's not a fun thing. It's happened many times.
Right.
But you would think we would have evolved at this point to be able to see it so as to not touch, right? We can see heat. You don't touch the fire because it's
Fair
hot.
point. Fair point. But if you saw all the spectrums of light, then you wouldn't be able to see anything. It would just be a mass.
Well, yeah, I would hope our brains would
Right.
then be smart enough to interpret, But anyway,
It'd be
that's
overwhelming. It'd be
philosophical.
a stimulus over them.
I feel like the 2.4 issue for Wi-Fi is probably the biggest killer of Wi-Fi that no one talks about. The biggest silent killer. Nobody, people that are everyday people don't necessarily understand it. They just think it's broken, and then they just walk away from smart home products. And then even people that have been doing smart home stuff forever still don't necessarily understand it 100% completely. You see people redo their entire, smart home system in order to fix problems like that and don't know if it's actually going to work or fix the problem.
And it's really funny, Vinny, because I have friends who know what I do for for a living, right? I mean, I've turned this hobby into a career, so they know what I do, and they tell me all the time, "Ugh, that smart home stuff, none of it works." I'm like, "What? What do you mean none of it works? This is how I feed my children. Like, of course it works, right? I mean, well, I don't feed them anymore because they're all adults, but
But here's the problem, though, is like if you replace someone's like I've helped people out, and then a light switch always works. Always, like a normal light switch, a traditional light switch always works, right?
Yep.
If you replace it with a smart switch and it's great, but one time it doesn't work, they're like, it's over, right? This thing's terrible.
The whole
So-
industry is at fault because that one light switch didn't work that one time, right?
Yeah.
Or I laugh all the time because my kids, they've lived with automated homes their entire lives, right? And when something doesn't work, they immediately think it's a problem with the technology, not a bulb burned out. Because
I had that. Oh my gosh,
bulbs burn out, right?
I did
I mean-
that. I changed everything in my house, and then I was like, oh, the bulb was. I had the same thing. Tested everything before I tested the bulb, and it was the bulb was burned.
So
Yeah.
it just, it's the way that we look at these things from a technological perspective. It's typically the more complicated problem, not the easier problem. And so you just assume that it is. But, that's one of the things that I'm working with a number of companies on that I think AI will be able to tackle. I'm working with a company now that is developing an AI chat bot, essentially, that will fix your smart home. Because what it does is it has enough diagnostic ability that it can go and look to see where the problem lies. So let's say the light above your desk is not going on. You can say to it, the light above my desk is not going on. And it will go and do things like check for the power and check for connectivity and check for the RF and then come back to you and say, oh, well, somebody turned off the light switch because I noticed that device has no power going to it right now. So can you check to see if the light switch is on? And then you go and you turn the light switch, and then it takes care of the back end stuff as well. Because let's say the light switch has been off for 12 hours and it's fallen off the network. It will then go and reestablish the connections for you.
All right.
So we're getting to the point where those kinds of learnings are going to be applied to smart home, and it's going to improve the usability of it without the 1-800 tech support call. The other thing that it will do is set up scenes for you very easily as well. One of the things is, I'm a New York Giants fan, unfortunately. I know. Take solace. It's okay. So
listen, we're Vikings fans, all right? So
all right. Well, then you and I can
Well,
commiserate.
Go sports.
Well, Brandon's yeah.
But the bottom line is, I could say, hey, when it's game time, set my colored light bulbs to Giants colors, but only if I'm in the house. And so it knows that I'm there. It knows the difference of the time, because obviously the Giants game is not always on the same time at the same day at the same place. And then, you can also say things like, if the Giants score a touchdown, flash the lights. Of course, I'd never get to see the lights flash, but that's beside the whole nother topic.
You don't know if that
I'm a
automation is
diehard
broken or not.
Yankee fan too. We're doing much better off in the Yankees than. But that being said, the AI can set things like, hey, if my garage door is open on Tuesdays after 10 o'clock, but the kids' bikes are still on the driveway, send me an alert. And it will collect all that data and then do that. And we've done some pretty deep dive testing in people's homes where we have all of those sensors, and the AI is really good. And it's actually getting to the point where it can do all of those things.
I think that's what it's going to take for full adoption for everybody to get the smart home, because people don't want to mess around with programming their hubs and all that stuff.
And the truth is, they shouldn't have to.
One of my favorite things when I first got into Z-Wave was like going out to like the hub manufacturers, and I could find all these different devices and go, how could I like get this to play with that? And I found all these companies I had no idea existed before, and even solutions to problems that I didn't know I had. But recently, you guys had a big rollout. What can you tell us about that?
Yeah, so very exciting. Again, because of interoperability within the Z-Wave Alliance and the Z-Wave architecture, we took the time to put together a product catalog, and we've actually published out that product catalog on our website, and it contains all the certified product. And so you got a question like, will this long range device work with that long range device? Or how do I implement this type of sensor because I want to solve this problem? Or which hub, can help me because it has these various protocols in it. All that information is contained within the product catalog. And so it's a really great resource. We're going to maintain it on a very regular basis. So as new things come about, we're going to be adding into it. It is very comprehensive, but remember, there is not every single member likes to be in the catalog. So I would also recommend that you do your own research, but it's a really comprehensive way for members to contribute to the Z-Wave ecosystem and get the word out. Right? Because some of our members are smaller companies. They may not have, as deep marketing budgets as some of the big guys out there. And we try to help them as best we can. But the product catalog is a great way to get the word out. And then a great way for users, if they've got a problem that they're looking to solve, to be able to use the catalog to find the right product for the right application. And that, again, is been a focus of our conversation here today, because I feel very strongly in the fact that the way that Z-Wave has really succeeded is we put out great products that solve the problems that consumers are dealing with.
All right. So now you're going to be at CES, which is coming up in just a few weeks here after this episode goes live. Is there anything you want to spoil? Any surprises? Let us know what's happening out there, or what should people expect at CES?
If I spoil surprises, then I get in trouble. I'm sorry. All of a sudden, I have this reflection.
You're the chair, man. You can do what you want.
Yeah, right. Please remember, I'm just a volunteer. They'll throw my butt off just as quickly as they asked me to be here. So, no, some really cool stuff though. We are going to have the ballroom again. So anybody attending CES, please make sure to come and see us in the Titian Ballroom, which is in the Venetian. We've been in the Venetian now for quite a few years. It's where all the smart home and smart health and all of those things are. You can also check out Eureka Park while you're there. One of the things we haven't touched on at all is my other major volunteer position is I'm a member of the Consumer Technology Association, been a long-standing member, been a member of that organization for more than 25 years now. I chair the trade policy working group for the CTA. And of course, the Consumer Technology Association is the group that puts on CES every year. They do a phenomenal job. This is going to be I've lost track now. I think 42nd, 44. 1984 was my first year at CES, and I have not been born yet.
He's old.
Yeah, I know. See, I'm old. I'm sorry. But yes, I've been going since 1984. My dad was in the technology business. If people know me, they know that. I have not missed one other than the COVID one, and then I was virtual, but I have not missed the CES since 84. Very excited. It's my favorite week of the year. But the Z-Wave Alliance, we will have a pavilion, a ballroom full of members. We'll have some really great fireside chats. We're going to talk about manufacturing. We're going to talk about Z-Wave long range. We're going to talk about the new command classes. We're going to talk about some new product. And we're also going to talk wink, wink, nudge, nudge. Oh, there may be a new bridge that we're going to talk about. But a bridge to where? Come and find out. So there's your little
matter of fact, huh?
Yes, where Where would that be? There you go.
Uh,
No giveaways, but we're very excited about CES. It's always a really great opportunity for the members to get together, for us to talk about the coming year. There's a lot of great initiatives that we're working on at Z-Wave Alliance for 2026. So please come on down and be part of it. And CES is just, like I said, it's my favorite week of the year. I love going to CES.
Can you make sure that do you have any pictures of CES from 1984?
I probably do.
I'd like to see what that looked like.
Little
It'd be
Avi
really interesting.
tweed. So I used to have this really nice tweed sport jacket with the little leather elbow,
Tweed.
the little leather elbow patches.
Oh, nice.
It's probably still around someplace, but yes, there's probably pictures of me somewhere in.
Would it still
Did
fit?
like Nintendo go to these? Like what kind
So
of
back
cool
to, so I
products?
can tell you that I have been a part of the announcement of the VCR. I was part of the announcement of the DVD player, the CD player, the Blu-ray player, the first Xbox, which just had its anniversary the other day, the first PlayStation. So I have seen a lot. The first cellular phones, when we first went in '84, cellular phones were still being carried around in a bag, right? My dad had an installed cellular phone in his DeLorean back in the day.
Whoa,
Yes, we were
cool.
geeks.
I think we
I
need
come from
to.
a long line of geeks.
I think we should do another episode on just the history of technology with you
Yeah.
here. We'll do
We
another.
could, I
I'm
will
dying to know
do my
like what was the
research. I
coolest
will-
thing you saw
Yeah.
that didn't come to life.
Oh, there have been many things that have not come to life. I mean,
Well, I mean
there
that's
have been some-
CES in general. It's like
yeah, there have been
it's
so
unveiled as like vaporware 101.
Oh, what
But maybe something that like you thought actually could come to market and then just for some reason didn't.
So it's funny. We talked a little bit about me not figuring out doorbell cameras. I'm usually pretty good about walking around CES going, yes, absolutely not. That won't be a thing. And then yes,
There's a
and my
lot of
track
that, by
record
the
is better than a batting average. Like I've got a pretty good track record of sniffing these things out. But I thought Betamax was better than VHS. Many people did.
I mean, it is.
Sony,
From
It
a
is.
technical
There's just a
perspective.
certain
right?
industry
Technical
didn't pick it
perspective,
up.
it was, but Sony didn't want to pay to play, right? You know, the folks at JVC were like, "Here, take it, go." Toshiba, JVC, Panasonic, they were willing to give it away, whereas Sony was like, "No." And that's actually the mistake that they corrected at Blu-ray, because HD DVD was a better solution than Blu-ray, but Sony was like, "No, come, we'll pay you to put your content on
Mhm.
Blu-ray." So that was a pretty big win. Two-way, it was interesting. I saw two-way video much earlier. You know, two-way video was actually shown at the 65 World's Fair, right? So two-way video was like a big deal in the 80s. Everybody thought that we would have telephones with video cameras in them. That never came to pass because the cellular phone essentially did it quicker. And so we never had two-way video because the infrastructure never really existed to do it.
So
But I
like
remember
in your
seeing a
house you
lot
would
of
have
two-way
this?
video. You know,
Interesting.
for those of you who are Disney fans, you remember when Epcot first opened, you'd run to the bottom of Spaceship Earth to make your restaurant reservations, and it was a two-way video link. So you'd stand at a telephone booth with a two-way video link, and they could see you, and you could see them, and you'd make your video. And that was like 1982, and everybody was excited, and they were gonna be like, "That's the way it's gonna be. 5 years, you're gonna have video phones. You're gonna see." Yeah, we never got our video phones, right? We never got our self-loading dishwashers. You know, we never got that. There was a lot of Jetson-esque kinds of things that I have seen over the years that we have not fulfilled the promise of, um, and mostly because they were so forward-thinking that the infrastructure didn't exist to really implement them. And now with the ubiquity of networking, they do exist. And so now we're starting to see a lot of these connected devices do the things that we always thought were going to be possible. But the biggest vapor was probably two-way video telephones. Like that was a big deal. Everybody thought that you were going to like sit and talk to your secretary when we had secretary. I mean, we don't even have secretaries anymore, right? Like that's not even a thing anymore. People they do emails.
Mhm.
But yeah, I remember when AOL and Prodigy and CompuServe came out, and
Yeah. Was it exciting when Ben Franklin went out and got the key on the kite and got shocked with
yeah, I'm not
electricity?
that old. Come on, Pete. Gee whiz.
Sponsorship canceled. We were so close, Pete. He was
Well, Avi, thank you so much for joining us today. We do look forward to seeing you at CES. We'll for sure come stop and say hello. Before we wrap up, you want to tell people where they should look for information about you or the Z-Wave Alliance?
Absolutely. So the Z-Wave Alliance is at z-wavealliance.org for all of you folks who want to come and join. We have many programs that support manufacturers and developers. We actually have a new program called the Accelerator Program, where you can join for as little as $2,500 a year and give you access to all of the tools and all of the resources, and then we will help you with the development cycle of your product. Consumers can find it at z-wave.com. They can find information in the product catalog out there. You can reach me at Avi Rosenthal. I am at blueconnectpartners.com or on LinkedIn. Facebook, LinkedIn, I'm everywhere. But Blue Connect Partners is my day job. That's how I put the monies on the table. You can reach me there as well. But thank you very much, Pete, Brandon, Vinny. It's been a pleasure being here with you today. Really a great conversation. Thank you.
Yeah, that was great. And maybe we'll have you on again in the future. It would be awesome. So on behalf of Vinny and Brandon, this is Pete. Thanks for watching. Please subscribe and like and all the things. We'll see you next time.